So alam naman natin na before kasi meron tayong theorem of Pappus which it was able to determine the volume when the figure is regular, and it's a lot easy, 'di ba? When you have a theorem of Pappus to determine the volume using the geometrical centroid and all of this. But what happens when the system is not in equilibrium, or the center of mass or the center of gravity is somewhere in this laminar region wherein you couldn't actually pinpoint that by just a mere inspection or by just using your knowledge in the previous discussions. So here comes a point where we need to determine the moments in the center of mass and the centroids of a certain irregularly shaped figure. So if you have a moments and then center of mass or planar lamina, so this is a thick or flat plate of material of constant density called the planar lamina. So yun yung tawag natin doon, no? The density in this case would be considered as the mass per unit of area. So for any planar lamina, if you talk about the density, that's just the mass per unit area. Kasi syempre, this is an area, it's not a solid figure. So syempre, that is the mass per unit area. So the moment is given by this equation. The moment, kasi diba, the moment is actually pwedeng x and y axis yan. So, kapag gusto mong hanapin yung moment mo sa x, that is actually the density multiplied by AB, of course, f of x plus g of x, and divided by 2, and then you multiply this by the difference between these two equations. So, kasi, di ba, this is your first function and this is your second function. So, technically, if you use dx, the represented triangle would, a rectangle, would be the upper curve minus the lower curve. So therefore, if you want to determine that, that's just simply the sum of the square of first function and second function. But for m sub y, since we'll be using dx in this case, so that's just always the difference between this f of x and then minus g of x, and then some distance x, so you have to multiply that with x lang. So yun lang yung concept ng ating moments. So usually parang ano lang to, top curve and minus lower curve pagka x, and then pag dy naman is top curve minus lower curve times x. So yun lang yun. Itong f of x plus g of x over 2, parang you take the average of them. Yung ano yan. So ganun yung concept niya. And then the center of mass of the centroid is, if you have already yung m sub y, you divide that by the mass of the planar lamina, and then for y, you have m sub x divided by the mass of the planar lamina. So remember, kapag x centroid ang hinahanap, that should be m sub y sa numerator. So opposite sila, no? Baka malito kayo kasi isipin nyo, pag x is to x, so baliktad sila. If it is the x bar or the centroid, coordinate centroid at x, that would be the moment of inertia at y, and then for y, that should be the moment of inertia of x divided by the masses of, or the mass of the lamina. The theorem of Pappus, I'll be skipping this because I've already discussed this, and we'll have the fluid force and fluid pressure. So basically, this fluid force and fluid pressure, so hindi ko na siya masyado i-discuss about yung ano ba yung fluids, ano ba yung pressure, alam niyo na naman yan. But the concept here is just the fluid force is the pressure times the area, alam niyo na naman yan, no? And the formula for finding the force is simply the weight, I think this is the weight density, is that tama? Weight density, that's the weight per unit of volume. That is the integral from c to d. So as you'd be looking at this figure, yung c to d, that is the lower point up the upper point. So parang ganun siya. Lower limit, upper limit lang din. And then h sub y. So h sub y is simply the distance from the x-axis going to that certain sheet that you're representing. Kanina parang ginawa natin to sa volume. And then yung L sub y would be the length of that certain material or the vessel usually. So yun. And then ito sinabi to, where h of y is the depth of the fluid at y, and L sub y is the horizontal length of the region of y. And that is the formula for finding the fluid pressure and fluid force. So technically, kapag meron ka ng fluid force, so technically pag dinivide mo siya sa fluid, sa area, then that you'll be getting the fluid pressure. Pag multiply mo siya sa pag dinivide mo siya sa area, you would be getting the pressure na. Okay. Pero for this case kasi, force ang hinahanap natin, hindi siya area. Hindi siya pressure. So I think that's all for the discussions, and let's head to the problem solving. Okay, so let's have the first one. And in this particular case, let's disregard the formula na binigay natin before muna. Kasi in this particular case, you're given with a lot of objects, A, B, C, and you're given with some locations in the Cartesian coordinate system. So for this particular case, the center of the mass can be calculated in a way na you can use the mass of that certain object, let's say mass of A, multiplied by its coordinate its coordinate, and then the mass of B times its coordinate, x coordinate, and then mass of C, and then x coordinate of C. And then you divide this by the sum of all the masses that you have. So this is the center of mass that could be solved from this given. So this is only applicable for this case, but if you're given with an equation, then we'll be solving for the planar lamina. So therefore, in this case, this is equal to that's 8 multiplied by 0 plus 3, negative 1 plus 10 times 3 divided by 8 plus 3 plus 10. Okay, and this gives you the value of the x bar, that is 9/7. And the same thing goes for y bar. So this is the center of mass for this particular case. So that is 8 times 3 plus 10 times negative 2 plus, ano pala siya, 3. So plus 3 times negative 2 plus 10 times negative 4. Okay, and then you divide this by the same sum of mass, so 8 plus 3 plus 10. So this gives you negative 22/21. So therefore, you'll be reporting for the center of mass that's located at 9/7 and then negative 22/21. Okay, so this is how it is done when you're given with a lot of objects with their own masses, and then they're located at a certain point on the Cartesian coordinate system. So what if we try using naman yung ating planar lamina? So in this case, we'll try to solve for number 2. So find the moment of mass. So again, moment of mass is m sub y, m sub x, not the center of mass na x bar and y bar. So find the moment of mass from the x-axis for y is equal to x ln of x plus 3x, and y is equal to 1 bounded by x equal to 3 and x is equal to 6. The surface density is equal to 0.34 kg per unit squared. So let's have it here na lang siguro. So sabi dito, meron actually tayong equation, and then yung isa niyang equation na we need to determine is ano ba yung g of x. So dito, y is equal to ln x ln x plus 3x. Okay, and y is equal to 1. From the x-axis yung ating moment, diba? And then bounded by x is equal to 3 and then x is equal to 6. So surface density of 0.34 kilograms per unit squared. So importante itong yung moment of mass from the certain axis. Kasi if you'd be looking back here, sabi dito, the moments about the x and y axis are, so technically we'll only be using yung mga x and y axis natin as our reference. Pero let's see kung meron dito tayong example na we could utilize para hindi lang tayo lagi sa x axis nagmo-moment. But I think dito yata is x axis lang, ayun, or y axis. So anyway, let's have it here. Ano ba yung magiging values natin? So technically, you could just think of this as this is your f of x and this is your g of x. Okay? And then sabi natin before, if you have m sub x, that's the moment, you could just have it as the integral from a to b, so that is 3 to 6. And then ano ba yung f of x plus g of x mo? So that's x ln of x plus 3x plus 1. Okay, divide this by 2, all of this by 2, and then you multiply this by x ln of x plus 3x minus 1. Ayan. So ito na yung f of x mo. This is your g of x, and ito yung plus natin na sign. Now for this case, ito yung f of x, and this is your g of x, and that is the negative sign. So we're just adhering with the formula na presented dito sa moment of mass. So moment when it comes to x-axis, diba, dx. And then we multiply this by the density, which is the amount of mass per unit area. So dx. So we're done with the construction of the mass. So therefore, the moment of mass in terms of x, so you can now substitute yung density natin, that is 0.34. Okay, so from this, the value would be equal to 222.2901. So the unit is kilogram units. Kasi remember, this is per unit squared. But then again, since this is in the third degree and then you integrate that, so magiging cube siya. Technically, that will be cubic units divided by unit squared. So may matitira sa ating units. So therefore, the moment of mass with respect to the x-axis is 222.2901 kilogram units. So pag with respect to y, so that's m sub y. Okay? So you can just look back again naman dito sa ating formula natin. So ito yon about the x-axis, so ito yung about sa y-axis. But then again, pag center of mass for the centroid, so you use the opposite parang variables. Okay, so that's it for number 2. Now let's have number 3, and hopefully you can do number 4 and 5 from this. So for number 3, what we have is we need to find the x-coordinate of the center of the region bounded by y squared is equal to x plus 3 and x plus y is equal to 1. Now there are two ways we can solve for this. It's either we use the horizontal or the vertical element or the horizontal element. So based on the graph, as you can see from Desmos, this one, you can see it from here na if you'll be using the vertical strip, we'll be having two partitions here. So the first area would be the left at this point, so this point going to that point, and then the second area would be coming from this region. So basically, it is a lot easier for us to use the horizontal strip. And in your formula kasi, we don't have any formula for the horizontal strip. Vertical lang yung given. So let's derive the concept using, or let's derive the formula using horizontal strip. Now this is the snapshot of the graph, and I just want to show you how it will be derived from this expression. So remember, if you try to use yung horizontal strip, which is a lot easier, so this would be your f of y, and this is your g of y. So remember, if we're asked to determine the centroid, so that is the x-coordinate using the previous concept, no? So this is some centroid of this one would be something like around here. So maybe it's around here. I actually do not know, no? Pero if that is the case, then paano ba natin siya hanapin? That's just simply m sub y over m, which is the mass of the lamina. And remember, your m can be interpreted as a to b and then f of x minus g of x. It simply is the area of that particular region that you're concerned with. So since hindi naman tayo f of y and g of y, so therefore yung m natin would be something like cd, and then this would be f of y and then g of y dy. So that's for the mass. But how about the m sub y equation? So you could just think about yung ating y-axis dito, diba? M sub y is the moment of mass from the y-axis. So you can just take a look at the y-axis and then point out the center of this representative horizontal strip that we have. And how do you get that certain region wherein it's the center of that certain horizontal strip? Diba, you have to take the average of these two. So therefore, m sub y is given by the equation that is similar to the m sub x of the previous one using the vertical strip. So that is m sub y, that is equal to the unit mass density from C to D, and then we multiply this by f of y plus g of y divided by 2, okay, and then we multiply this by f of y minus g of y. So that is how you that's how you derive the formula using the horizontal strip. And if you want to determine the x-coordinate, the y-coordinate in this case, so that's the distance from the x-axis, so ito yon. And how do you get to that center? So diba, to get to that center, that is any y value dito, diba? So from that, your m sub x becomes density from C to D, and then that's just y, and then the difference between these f of y minus g of y. So para nangyari lang sa kanya is nabaliktad lang yung form, pero the concept is just the same. So from this, m sub y will be determining our m sub y from this equation. So we first need to determine yung mga points of intersection natin dito, and in this case alam naman natin na meron lang tayong dalawa, which is this one and then that one. So you could just equate yung ating mga equations. So diba, we have y squared is equal to x plus 3, and then we have x plus y is equal to 1. So from this point we could say that f of y is equal to 1 minus y, and then yung ating g of y would be equal to y squared minus 3. And therefore, we could just equate these two, so you'll be able to obtain the values for the lower limit c. So from this, the value of c, as you can see from the figure, that's 1.562. So to be more exact, that is, or c is the lower value, so we'll take this one. So that is negative 2.5616, and then for d, which is the upper value, so that is equal to you can see it from here 1.562, but I'll be more exact, 1.5616. And I'll be storing that to my calculator para hindi tayo magkaroon ng exact value, no? So that's m sub y, the lower limit and the upper limits of m sub y. So therefore, m sub y would be equal to the integral, or the unit mass density, from negative 2.5616 to 1.5616, and that is f of y plus g of y. So f of y is where is that? 1 minus y, and then your g of y is y squared minus 3, and then you divide this by 2. Okay, and then we proceed with the difference, so that is 1 minus y minus y squared plus 3, since it's a difference. So therefore, m sub y, in terms of the unit mass density, that's density times negative 2.33 6426521. Okay, so I'll be storing this value to be exact para sa ating future computation. And then the next step that we have to do is to divide this by our m, which in this case m is simply the area of that certain figure. So from this case, we could just say that x bar would be equal to the density times negative 2.33. So ba't ba naging ano yon, parang area na lang, no? So remember, sabi natin ang density natin is the mass per unit area. So therefore, if you have the mass, that is simply equal to the density times the area, and you can just have this as divided by the x bar is divided by your density area, which cancels out the density, unit density, so we're left out with the area. That's why you can represent that mass in terms of area. But if you want to do that, you have to make sure that you're canceling out yung density portion dito, no? So that's negative 2.33642651. We divide this by the area, and the area is simply the this parang portion na to, diba? Integrated from this given. So that's the integral from negative 2.5616 to 1.5616, and then that's 1 minus y squared plus 3. Okay, so this gives me a value of, now you can actually determine the area if you want. So gawin natin muna is isa-isahin natin yung values. So I'll be integrating the denominator para at least kita natin yung values ng area. So this is negative 2.3364 wait. So this is equal to, dito ko nalalagay, so that's negative 2.33642651, and then the area is 11.68213261. That's the total area of this whole region. Okay, and if you try to divide this answer, you'll be getting negative 1 over 5. Ay, ba yan? So that's negative 1 over 5. Okay, so this is the answer for the centroid, that is the x bar, that is the center of the mass from the y-axis. So that's negative 1 over 5. And that's a very easy computation when it comes to using the horizontal strip, kasi kung mapansin nyo, isa lang yung ating kinonsider. But what happens when we try to solve this using naman yung ating vertical strip, which of course we'll be using two values here. And remember, we'll be utilizing the concept from number 1 na if you have the mass and you have the center of the mass, you multiply it to the center of the mass and then divide it by the total masses of the objects that you have. So we have here the first strip, and then this is the second strip. And remember, we need to determine the mga points na kailangan natin. So remember, in this case, since this is the farthest one, the critical point here is at -3. So we'll be having x sub 1, or let's say this one is your, paano ba natin? A, B, and then let's say this one is C. Para at least gets na natin. Diba? So, yung A natin is the x value of this one. So, that's -3. And then, ano ba yung B natin? So, pwede naman yung makita, -0.562. And then, by solving that and equating it to the previous equation, diba? That's -0.5616. And then, yung C natin is, actually, that's 3.562. Oh, sorry, 5615. So, ito yung mga values natin na nakuha. And basically, these are just parang inequate natin mula dun sa y, and then nakuha natin siya based on substitution lang dun sa mga original natin na values. So, hopefully ay tandaan nyo na yung kung paano maghanap ng mga values ito ng mga limits of integration. So, we'll be using A to B para dito sa first area, and then B to C for the second area. Then, I'll be using muna, or I'll be solving for the second area muna dito. Kasi ito yung ating parang, let's say ito yung ating area 1, and this is your area 2. So, I'll be solving muna for area 2 para mas madali siyang ma-solve. Kasi this area 1 will be, syempre, same equation lang yan. So, ihuli natin yan. So, for area 2, what could be your m sub y? So, m sub y is still the same concept dun sa previous one kasi we'll be utilizing na yung ating vertical strip. So, diba, any distance from the x-axis, from this case, so it's just the value of x multiplied by the distance of whatever is this one. So, you could have the equation that is the integral from this point, that's -0.5616 to 3.5616, it should be 6, and then integrated from x multiplied by, that's f of x minus g of x. So, ano ba f of x natin dito? F of x is, my equation, we have x plus y is equal to 1, and y squared is equal to x plus 3. So, your f of x is actually equal to 1 minus, 1 minus x, and then yung g of x mo would be equal to the square root of x plus 3. Okay, so from this, that's x multiplied by 1 minus x minus this portion, and this portion is actually negative kasi that's the lower portion of the parabola, so that's, kasi this should be positive or negative. So, minus the negative, that becomes positive square root of x plus 3. Okay, dx. And basically, this is your m sub y. And we can determine din yung ating, of course, I have to incorporate yung ating unit mass density dito. But then again, since wala naman tayong value, so m sub y would be equal to the value of this one, and it gives you 5.46660447 in terms of the unit mass density. So, gawin natin itong 1. Okay. So, ito na yung atin for m sub y1. And how do we determine naman yung ating, m? So, yung ating m would be simply, di ba sabi natin that's the density, or m sub 1 is m sub 1, and then area. Ay, wait. I forgot. This should be 2 pala. Kasi we're dealing with the second area. So, this should be 2. So, 2, 2. Okay. So, yan. So, m sub 2. So, from this case, yung m sub 2 natin, we can now compute for our a sub 2. And in this case, yung ating a sub 2 would be yung ating mass. Pwede na natin siyang sabihin na ganon. So, a sub 2 would be equal to the integral from -0.5616 to 3.5616, and then that's just 1 minus x plus square root of x plus 3. And this gives me a value of 6.605113.854. Okay, so knowing that this is your area 2, or it could be the mass 2, so therefore, yung ating so yun na yung ating mass 2. So gawin natin na wag ng area, gawin natin tong mass 2 na lang, m2. Okay, so since meron na tayong M2 dito, actually pwede natin ito i-disregard kasi in-assume na natin na M2 to eh. But then again, let's continue muna. So we have M sub y1 that is equal to density 1 from negative 3 to negative 0.5616 x multiplied by ano ba yung distance or difference between these two. So that's 2 times square root of x plus 3. So yun lang naman yan, the x. And this gives me the value that is equal to negative 7.80303 0999 density 1. Okay, and then for our m sub 1, that is simply the area. So considering the area, we have negative 3 to 0.5616. Okay, and then that's just 2 square root of x plus 3 dx. So this gives me the mass 1, which is the area 1. So this gives me the value that is 5.07770 Okay, so what happens next? So x bar is actually determined by simply having m sub y1 plus m sub y2 divided by m1 plus m2. So how is this possible, no? Kasi meron pa naman tayong density 1, density 2, so di pa natin ito makakompute. But this is actually possible when you disregard density 1 and density 2 na. Kasi you have already incorporated that m sub 2 is equal to a sub 2. Kasi what if we go back to the concept na this is just the areas. So area 1 lang, area 2 to, and then area 1 to. So how is this possible na pwedeng ito na yung gamitin natin? So as long as you disregard yung mga density 1, density 2, so okay na yun na yung gamitin. So therefore, the x bar is 5.466044478 plus negative 7.803030999. You divide this by the total mass, so we have 6.605113854 and then 5.077018752. So therefore, x bar is equal to, so this gives you negative 1/5 as well. So this could be your final answer. So you might be thinking na bakit kinancel yung density 1 and density 2? So here's the catch, no? So remember, this is your density, this is your area 2, no? But remember, if you want to determine the centroid of this particular area only, let's say sa area 2. So for area 2, yung inyong centroid na x sub 2 bar would be equal to, ano ba yung equation niya? So that's simply this my2 over m2, which in turns, ano ba tong my2 mo? That's, saan ba yun? 5.466 for the density 2. So it's like 5.466044478 density 2 divided by area 2 and then density 2, which cancels out density 2, which divides you with the area. So therefore, you can determine yung x sub bar 2, which is simply the quotient of 5.466044478 divided by this area 2, that's 6.6051184, which gives you the centroid of this area, and that makes a perfect sense. Kasi remember, the other formula here is that if you have the mass 1 multiplied by the centroid 1, okay, and then you add yung mass 2 and then the centroid 2 divided by the total area. So remember this portion here, m1 y bar 1, diba ito galing lang din siya sa my2, which is this part. So therefore, it makes sense na pwede mo siyang gamitin by just simply removing yung inyong mga portion ng density. So yun lang naman yung concept nun. So ganun lang siya kadali. If you already have the moment, just disregard yung inyong unit density upon application sa x bar. Just explain na upon solving for a sub 2 and then cancelling out, so pwede siyang makancel. Makancel nga kasi kinancel out mo na nga. So yun yung concept nun. Kasi if ever you'll try to, let's say, if you want to determine pa yung x sub 2 bar, so di-divide mo pa yan. So makakuha ng x sub 2 bar, which is okay lang naman para ito yung general concept. But then again, i-multiply mo uli siya dun sa mass, which gives you the moment. So parang pabalik-balik ka lang. So wag mo nang gawin yun. Ang gawin mo na lang is just determine the moment in terms of the density, and then you divide this by the total mass and then disregard the density at the end of the computation para mas madali. Kasi it turns out na kinakancel lang din naman natin siya. Okay, so ganon. So hopefully and this gives you negative 1/5, which is the same result. So hopefully nag-gets nyo yung concept ng moments and mass. And I want you to solve for number 4 and number 5. Hopefully ay masagutan nyo siya using the same concept na. And then I think we're done with the last 2 items. Okay? So ano ba tong last 2 items ito? Okay, so this one is the fluid pressure, fluid force. Okay, so let's move forward na sa last 2 items. We have a ship is set to dock and places its anchor 7 meters below the surface of the sea. So the sea has a density of 1,300 kilograms per cubic meter. The anchor assumes a shape of a parabola. The width is 1 meter and the crown, which is the lowest part of the anchor, it touches the sea floor. So 1.2 meters yun from the top of this anchor, and what amount of fluid force is experienced by this object. So the first thing that we need to do here is to draw yung ating situation. So if I have let's say a coordinate system here and I want to create an anchor that is located at this, so parang seafloor tong 0, 0 natin. So assuming na ganyan yung seafloor, yung anchor pala seafloor na tuloy. That's the parabola, or that's the anchor. And that is, this one is 0, 0. So basically, sabi natin, yung crown niya is 1 meter. Crown. Yung range nito, yung nakabuka is 1 meter, and then yung crown, which is the lowest part, is 1.2. That's 1.2. Okay, so basically, if you want to determine yung ating value using the concept of parabola, we have x squared is equal to 4 away, because that's a parabola that opens upward wherein the center is at 0, 0. So what is the value of x? So that's 0.5 squared is equal to 4a, and then y is 1.2. So therefore, your 4a is equal to 5 over 24. So basically, the general equation of this anchor or the parabola is 5 over 24y. X squared is equal to 5 over 24y. So again, it is located 7 meters below the sea level. So you could just count parang this, diba sabi natin this is 1, and then 1 point, maybe it's around here, 1.2, 3, 4, 5, 6, 7. So hopefully ay medyo banda dyan. And that is the surface of the water. So around here. So ito is 7. So medyo nagsala lang. Pero that's 7 units from the surface, the seafloor. The fluid force can be determined by having the weight density multiplied by the of course by the integral from c to d, which is p of y and then l sub y, where l of y dy, wherein yung p of y natin is yung distance nito nung surface natin papunta dun sa representative natin na volume, or not really the volume but yung ating distance between these two, no? And then yung ly natin is the length, which is actually the just the distance between these 2 points. Ito. Okay. So let's determine yung ating L of y muna. So if it's the L of y, that's simply the distance between these 2 points. Alam naman natin na in terms of x or in terms of y, this is just simply the positive negative square root of 5 over 24y. And therefore, L sub y is simply the positive side minus the negative side, which gives you 2 the square root of 5 over 24y. Okay? And then, how about your p of y? So this comes the tricky part now. So the p of y is simply the distance, this one, the distance from the surface level going to whatever is your representative there. Kasi parang yung p of y na yun yung magiging distance niya from the surface to whatever point is you're referring to. So kung halimbawa dito sa point na to, then that's your p of y. Kung halimbawa dito, then that's your p of y. And then it goes on. So how do we determine that? So if you try to represent yung any distance from the x-axis to this as your y, therefore any distance na matitira dito would always be 7 minus y, kasi that is the distance from this point for the sea level to your any representative rectangle. So therefore, p of y is simply 7 minus y. Okay, so hopefully na-gets nyo yun. And then of course, the force would be, ano ba yung ating weight density? So sabi sa atin, 1,300 kilograms per cubic meter daw ang density. But it's the weight, so you have to multiply this by the acceleration due to gravity para maging weight density na siya ngayon. And then you need to integrate now from C to D. So pag C to D, that's just kung saan yung lowest portion ng inyong figure or the vessel. So dito, di ba, 0. And then ano ba yung upper portion niya? So that's 1.2. So that's 1.2. And then ano ba yung P of y mo? We have 7 minus y. You multiply this by 2, the square root of 5 over 24, and then y, and then dy. So this gives us a value of 64,071.072. And of course, the unit, you have to make sure that the unit is consistent. So dito, kilograms per cubic meter, you multiply this by meter per second squared. So basically, any mass kasi na you multiply with the acceleration to gravity, so it becomes Newton. But then again, since this is per cubic meter, so naka per cubic meter pa siya. So dito naman sa case na to, since this is two variables, is parang ano lang siya, single dimension multiplied with each other, so magiging square yan. And then in-integrate natin, so that becomes cubed. So therefore, multiply to sa cube, so we can cancel this out. That's why we're left out with the symbol, the unit that is in Newton, which gives us, of course, the unit of the force that we need. So that's 64,071.072. Okay, that's how easy it is for you to solve this number 6. And that's the same concept for number 7. You'll be looking at this number 7. It says here that there's a clock, kasi there's some kind of Atlantic Ocean exploration, and then there is a clock right there that they saw, and then it's below something like 1,200 feet below the surface level. So that's 1.5 feet in diameter, and the depth, so 1.5 feet in diameter, so circle naman siya. And the concept is just the same, so you just determine yung inyong L sub y, which is just the difference between these 2 points. So kung halimbawa circle siya, so you have to expect na meron diyang naka-square na part, so you just have to add those 2 squares at square root, ganun. And then the depth would be parang 1,200 minus y, so you should be able to get the same result. And remember, since this is in English units, you have to consider that the weight density of any mass is just the same as its density itself. So for example, it's 65 pounds per cubic feet, so the weight density is also 65 pound-force per cubic feet. So parang ganun lang din siya. Okay, so you don't have to like think about parang pag multiply mo pa sa 32.174, you can do that, but make sure you divide it by 32.174, so that becomes just constant, that's 1. Okay, so hopefully masagutan nyo yan, and if you have questions, let me know for this particular applications for the first part and then this second part, kasi we're done with the application of integration 2. So hopefully we can finish this, and as I see it, yung application 3 natin is di naman ito sobrang hirap talaga, sa totoo lang. This is just an application wherein you just have to incorporate yung mga unknowns natin and then just integrate. So for this case, yung application 3 natin, so ito yon, but that is the end of module 3. So hopefully we could just finish this in just one video. I think pwede naman talaga to. So ito, you will be dealing with the work done in the expansion of gases, and ano ba to, heat, and some reaction kinetics. So yon, and then we'll be dealing with the vector analysis and some concepts of multiple integration in the final set. So hopefully we can finish this. Okay, so ayan lang muna.